all of our tools are tools for stereographers, built by stereographers. One of the tools that we're very proud to present at NAB this year is our Dashwood 3D chart, developed in cooperation with DSC Labs. The whole point of this chart is to make calibrating your stereo rig just way faster. The most interesting thing on our chart is that it holds an iPad. This iPad allows us to show you dynamic information about your camera calibration and also acts as a slate. Of course, to utilize the iPad software, you need a Mac to process the signal and actually give you the feedback. And that's where a new product comes into play. It's called Stereo3D CAT, which stands for calibration, analysis, and tracking. So the first thing we see is that obviously our two cameras are not lined up. So we're going to bring up a very cool feature. This works directly with our chart, and that's our tracker. It shows us exactly how much disparity we have between the two cameras. Every stereographer knows how long it takes to align rigs. Typically minimum, you're looking at 15 or 20 minutes by the time you get it all aligned just by eye. We are attempting to speed that up by 10 times. Now on the chart itself, I actually get the exact same readout that I'm seeing on the Mac screen. So let's get rid of this rotational disparity first. We're within 0.04 of a degree. Now our zoom disparity, we're way out on the zoom. Now if we had prime lenses, we would just slide the two cameras back and forth on the sliding plate just to find the same field of view. There we go. Very sensitive, and let's just get it into the green zone. Now we have a vertical disparity, but from the looks of it, it's actually being caused by some tilt. So I'm just going to adjust that out here. Stereo3D CAT automatically detects what your stereo base is once you have your toe in set. So it's telling me that it's around 17 millimeters. So we're just going to bring this down to about 10 millimeters. So there we go, it's at 10. According to our chart, the rig is now calibrated. I'm just going to take my 3D glasses here, take a look at the scene. So what I'm seeing is it's perfectly parallel, and that means that everything is coming out of the screen. Our convergence is at infinity because the two cameras are perfectly parallel. And we can also look in anaglyph, side by side. We could look at just the left eye or just the right eye. Or we could use our depth analysis. A little more on that later. Like I said before, the cameras are perfectly parallel, so we want to show the client what the final product is going to look like. Just go into my geometry controls here, and I'm just going to shift the convergence. So now what we've done is we've converged on the center line of the chart here, and that means that everything behind the chart is going to be in positive parallax behind the screen, and everything in front of the chart is going to be in negative parallax, all by just moving a simple slider. So these are great tools for stereographers to communicate with the director or the producer exactly the intention of what adjustments you're going to make in post-production. Now most stereographers do many, many calculations while they're on the job. I can show you my notebook here. This is from the last shoot I did, where we have many longhand calculations. Now I still go and double check most of the math, but it got me thinking, why would I do all this when I could put all that in Stereo3D CAT? And I didn't want to just use some of the stereoscopic calculators available on the iPhone because they just give you an opinion. I actually want to visualize the final product. So that's why we created the Stereo3D Visualizer. Now the Stereo3D Visualizer actually shows you your scene by demonstrating a close object and a far object and the convergence point. So as we make those adjustments, and we can play around with the sliders here, you can see that everything moves on the screen to show you what the final scene is going to look like. And at the moment, we have selected a theater, which is a 30-foot wide theater screen. And we also obviously have options for the home, so we can switch to home. And if you're planning to show your content on a computer screen, obviously all the math changes. So I'm going to put it back on a 30-foot screen. And we're assuming that our sensor size is Super 35, but as you can see, we have settings for all of the different sensor sizes. As well, we have many different focal lengths of lenses. So we've set our stereo base to 10, our nearest object is 2, convergence is just just behind the primary object. Nice. Now, of course, everyone has a different interocular. The interocular is the distance between the human eyes. The average tends to be around 63, 64 millimeters. But we've put in settings here to go as small as 40 millimeters for very young children. So if you're shooting a film destined for young children to watch, you're going to want to be very conservative on your setting for interocular. Down here we have a very neat feature, which is the roundness indicator. It indicates geometric similitude between the object you actually photographed and the perception of the object on screen when you watch it. If we turn on the roundness indicator, the apple goes down to being an oval shape. So if we change the screen size, you can see different effects. The apple is almost completely flattened out on the small screen. Now let's go up to a really big screen. And let's bring the apple even closer to the camera. As the apple gets closer and closer to the camera, you can see that it starts to elongate itself in the other direction. It starts to look like a football. And over here on the parallax side, we actually see that the eyes are very crossed, and our negative parallax is actually starting to exceed the distance between the eyes. That's okay in negative parallax. In positive parallax, that's where you have to watch it, because you don't want these eyes to diverge. Let's just have a look at what happens if we increase the stereo base. If we increase it too far, the positive parallax in the background, which is these two images of these two trees on the screen, ends up exceeding the distance between the human eyes. And then, of course, the software gives us a little warning saying that we are diverging. So the idea with this tool is to communicate with directors and producers. And it allows the stereographer to show it to the director and say, you know what, this is where that object is going to appear in the theater. But, of course, we aren't always going to have the luxury of time to be able to pre-visualize each of those scenes. So at some point, we're just going to have to analyze our scene. Well, that's where the other analysis tools come in handy. The first one that I want to show you is the parallax inspector. The parallax inspector looks at your positive parallax in the scene, and based on the settings that you put into the stereopsis control panel, it tells you how many pixels wide, based on your output resolution, will be the native pixel parallax of your screen size. So for example, because we put into our stereopsis that we're shooting for a 2K digital cinema package, so that's 2048 pixels wide, and our theatrical screen, let's say we'll put it on to 30 feet wide, that's telling me now that my native pixel parallax will be 14 pixels, which is 0.7% of the screen width. So what this is telling me is that the distance between this vertical line and this vertical line will be the same distance between the eyes of our audience actually watching on that size screen. So it's going to be important for us to make sure that the positive parallax doesn't exceed that distance. So we can zoom directly in on this object and make sure that that one of the edges of our right eye is within the distance parameter of the same edge on the left eye. And as you can see, we're just fine right now. Now if we change our convergence point, let's say we converged a little too close to the camera, well now we've exceeded that distance and it's going to cause divergence when the audience actually watches the film. So this is a very, very useful tool. Now I'm just going to set the convergence back, and I'm going to show you one last tool that we're very excited about, and that's the depth analysis. So in this scene, it's showing me that the objects back here are green, meaning that they're in positive parallax, meaning they're behind the screen. The chart here has a red edge to it, and that means that it has negative parallax, and it's in front of the screen. So if I were to walk through the scene, right now I'm green, and as I walk forward, I am walking into the negative parallax area. Of course, we are continually working on features for this product, so please come by our booth in the 3D Pavilion at NAB 2011, and we'll show you Stereo3D CAT and the new version of Stereo3D Toolbox. We'll see you there.